These are the solutions to the upper remove test from the October half term. This is question 1. Now this question was put in the test because it's obviously just right-angled trigonometry in Pythagoras, and when we learn about non-right-angled trigonometry, we try to use that even though it's just a right-angled triangle. So the first question is just basic Pythagoras. To find the length of DG, we're going to use a squared plus b squared is c squared. So DG squared is 136, meaning DG is square root of 136, which is 11.7. Next question, find the angle marked x. Well, we can just look at that triangle EFG. We see that we have the hypotenuse and the adjacent side to x. So in SOHCAHTOA, we're going to be using cos. So cos x is equal to 8 over 10, meaning x is equal to the cos inverse of 8 over 10, which is 36.9. Okay, so this is how you should have laid out your answer as well, something like this. Clear algebraic working going down the page. Moving on. Okay, firstly, look at this question. It says find a formula for t in terms of x. It doesn't say in terms of x and k. So if you'd written in terms of x and k, then you've got it wrong. You need to find that value of k using the information from the question. So we state the relationship to start with. The relationship is t is proportional to x, which means t is equal to k lots of x for some value k. Substitute in the values we're given. 150 is 6 lots of k, because x is 6, t is 150, giving us k is 25. So that means that t is equal to 25x. From here, we substitute in 15 into the formula we've just created, giving us 25 times 15, which is 375. The next question is not much more complicated. We set t to be 600, and so we divide both sides by 25, giving us a value of 24. Moving on. If we look at how A gets to B, it's clearly a reflection, and it's in this line. And on this line, all the x values are -1, so it is the line x is -1. For the translation, we're going to move 2 units to the left and 4 units up. So I pick a corner, and then I draw that corner again, and draw the triangle the same orientation, label it C. Next question. There are 2 ways to do this question. I'll go through both of them. Firstly, you need to, I would strongly recommend drawing the line AC in your diagram. To find AG, first we're going to find AC. So we know by Pythagoras that AC squared, or AC, is the square root of 5 squared plus 7 squared, giving us root 74. Now I don't really need to change root 74 at this stage, I can just keep it as root 74. From here, to find AG squared, this is the same as AC squared plus GC squared. So I'm using that triangle that's sort of between, inside the cuboid. We know what AC squared is. AC is root 74, so root 74 squared plus 3 squared. Root 74 squared is just 74. And so AG squared is 83, giving you AG is root 83, which when you put it in your calculator gives you 9.11 to 3 significant figures. So this was the first option. It's the option that was chosen most often, but there is another option. To find the diagonal for any cuboid, you can just do this. AG squared, the diagonal from one corner to sort of the opposite corner, is going to be 5 squared plus 7 squared plus 3 squared. This will always work for a cuboid. You don't need to do the option 1, you can just do option 2. It's less intuitive, but then Pythagoras isn't necessarily intuitive itself. This is basically a 3-dimensional Pythagoras equation. When you do that, you get AG squared is 83, so AG is root 83. So it's much quicker, but maybe it feels a little less comfortable. The question below asks you for the angle between AG and the base, so we're looking for this angle theta. Okay, we know what AC is, we know what GC is, so we can just say that tan theta is equal to GC over AC. Notice how I'm using letters to define the sides, so from point to point. We know GC is 3, and we know AC is root 74, we found it earlier. So theta is the tan inverse of that, and when you do that, you get 19.2 degrees.